So thank you guys all so much for coming to the very first ever San Diego Pint of Science. We are absolutely thrilled to have this crowd here. So as Antonio mentioned, I'm going to speak to you about iron deficiency and hair RNA. Now, over 2 billion people in the world have anemia, mostly due to iron deficiency. This makes it the most widespread nutritional disorder in the entire world. Now, iron deficiency brings with it many severe risks, including impaired physical and cognitive development, poor pregnancy outcomes, reduced productivity in adults, and increased maternal deaths. Iron is also key in maintaining several body functions, including having healthy hair, nails, and skin. So when you look at your hair and your nails, that's there because of iron. Now, importantly, iron requirements increase at times of growth. So when you think about your biggest times of growth, that would be either when you're a young child or in adolescence, also during pregnancy. So what's really sad is iron deficiency hits hardest young children and pregnant women. In fact, in some areas of the world, over 40% of either preschool children here in the dark red or pregnant women in the dark red down here, over 40% are anemic. So you can imagine the consequences this is having for productivity, for health, for development. Now, when you look at where the highest prevalence is, think about how we currently test for iron deficiency. Does anyone know how we currently test for iron deficiency? Blood, exactly, which is a fantastic way to do it. But think about what comes with blood testing. You need sterile equipment. You need specialized people to be able to withdraw that blood, and you need refrigeration. Now look at where the highest prevalence of iron deficiency is. A lot of those places don't have all that. Here in the US, no big deal. We have tons of current medical labs, it's great. But out here, it'd be nice to have a different way to test for iron deficiency, right? Maybe something that's stable, portable, could be, mailed through the post, I don't know, hair? So let's talk about that real quick. I want everyone to either hold a piece of hair in your hand or look at someone's hair near you, okay? So look at this hair carefully, if you can. Hair is made up largely of cross-linked proteins called keratins, and these are surrounding dead cells. So how do we get RNA from this? Well, here's the important thing, is all those dead cells in the hair, they started somewhere. Each piece of hair has a story. So all of this hair started as live cells in this portion of the skin called the hair follicle. Now, as the hair grows, the cells die and become the hair shaft that you can hold in your hand. But in the beginning, they were live cells. And now here's the really cool part, is we've discovered that you can actually get the RNA out of those dead cells in the hair. There's still some RNA left there, and when we grind it up and extract the RNA, we can see what the gene expression was like. And importantly, hair is highly vascularized. So what that means is there's blood vessels that lead to the hair, or to the hair follicle, where the cells are initially alive and then dying to become part of the hair shafts. So this means that, think about this RNA that we're seeing in the hair shaft. That came from these live cells that were influenced by the blood vessels, which could easily be influenced by systemic disease, such as iron deficiency. So, sorry. What I want to tell you about briefly, and there's no slide for this, which is why I accidentally clicked ahead, I'm not used to that, but recently we have been working with a lab in Wisconsin that has a Rhesus model of iron deficiency. This model mimics human iron deficiency, but without all the complications that can come with other malnutrition. And in these Rhesus monkeys, we have gotten hair from them. This hair has been ground up, we've extracted the RNA, and what's really cool is we actually see a difference. So the monkeys that have iron deficiency, and these are young monkeys, just like, same age as we would diagnose it in humans and young children. These monkeys with iron deficiency have different gene expression. Different genes are turned on or off than those that have sufficient iron supply. So, of course, there's a lot more we need to do to know if there's a consistent biomarker, a consistent set of genes that are turned on or off with iron deficiency. I'm not suggesting that we have, a new diagnostic tool for iron deficiency, but let me remind you what we do know. What we do know is iron deficiency is affecting almost 2 billion people in the world. And a lot of these people are living in areas that don't have access to clean, sterile medical supplies or refrigeration. And I'm not suggesting that they have a sequencer nearby to sequence genes, but you know what? They probably have a post office nearby. And most of the samples that we have worked with have come through the mail. No refrigeration. They've been sitting out for even a couple months, and we can still get RNA out of them. So we can get it through the mail. This is portable. This is stable. And most importantly, we see clear transcriptional changes, clear changes in the gene expression in iron deficient versus iron sufficient monkeys. And we have a long way to go to get this in humans. We have a long way to go to make this a diagnostic tool. But I'd like to suggest that maybe it's time that we start looking for alternative ways, alternative methods of diagnosing people in third world countries and developing countries, and maybe start to untangle this mess of hair RNA. Thank you. Now, I intentionally wanted to keep it a little bit shorter just to give you an introduction, also because I knew I was following